All right, so Claude Fable 5 just posted 80.3% on SWE Bench Pro, and Gemini 3.6 Flash came back at 58.7%. That's a 21.6 point gap on the same benchmark, same test conditions. And these two models are not as close as the marketing makes them sound. Both models dropped recently, and if you're picking one for a real workflow right now, this matters. I'm comparing them across 4 tests: reasoning, speed, pricing, and long context handling. And every number I use is sourced from vendor docs or independent benchmarks, no sponsored takes, no cherry-picked demos. And honestly, the results surprised me, because the model that wins on raw intelligence is the one that could wreck your API budget on a single overnight agent run. And I'm not going to tell you which one yet. So this comparison is for engineers, builders, and anyone running AI in production who needs to know which model to actually pay for, because picking wrong means either overpaying by 6.7 times per output token or shipping a model that breaks on complex tasks when it counts. Test 1, multi-step reasoning and coding accuracy. The thing that actually goes wrong when a model fails, this is you hand it a real bug, it confidently writes code, the code compiles, and then it silently breaks something else downstream, and you don't catch it until the pull request review or worse, production. That's the failure mode we're stress testing here. I looked at the SWE Bench Pro numbers, and what got me was how clean the gap is. Fable 5 hits 80.3%, Flash sits at 58.7% on the same benchmark with directly comparable scores. And BenchLM puts Fable 5 at number 3 out of 250 models overall. Worth noting, Flash's deep SWE figure of 49% is a different test setup, so I'm not mixing those two. Take it with a grain of salt though, because Flash jumped from 37% to 49% on deep SWE version 1.1, which is a real generational leap for a Flash tier model. And there's no BenchLM entry for Flash, so we can't do a clean apples to apples on the leaderboard score. The 21.6 point SWE bench gap is real, but Flash isn't standing still. Fable 5 takes this one. I was expecting a closer fight on coding, but 80.3% versus 58.7% on the same benchmark is not close, and the lead actually grows on longer, more complex agentic tasks across 7 business task categories in independent testing. Score is Fable 5 1, Gemini 3.6 Flash 0. Test 2, response latency and throughput speed. The concrete failure mode here is you build a customer-facing feature, push it to production, and users start complaining the app feels frozen. So you check the logs, and your model is sitting there thinking for over a minute before it sends back a single token. That's a real problem. What got me here is that Fable 5's 109-second time to first token isn't a network issue, that's thinking time. And you can't turn it off because extended reasoning is always on. I was expecting maybe a 10 or 15-second overhead, and 109 seconds is roughly 41 times the tier median. Flash maintains Flash level latency, though I'll be honest, there's no published tokens per second figure for Flash to compare directly. Now, these two models have pretty different latency profiles, so the comparison isn't perfectly symmetrical. Fable 5 does generate at 63.4 tokens per second once it starts, which is fast, and if your workflow is async or batch-based, that 109-second TTFT might not matter at all. It really depends on what you're building. Gemini 3.6 Flash takes this one, and I think the margin is bigger than I expected. Flash also burns 17% fewer output tokens per workflow than its predecessor, which cuts end-to-end runtime on agentic tasks. And Fable 5 has no fast lane option. That ties us off at 1 apiece, Fable 5 1, Gemini 3.6 Flash 1. Test 3, pricing per million tokens at scale. The failure mode is you prototype with a model, everything looks great, you scale it up, and the bill comes in at 5 or 6 times what you budgeted. Community data shows a multi-hour CRUD agent run on Fable 5 costs $23.70. And that's a real number that can sneak up on you fast. I pulled the vendor pricing docs directly, and here's what we got. Fable 5 output tokens run $50 per million, Flash output tokens run $7.50 per million, and that's 6.7 times cheaper at list price. At batch rates, the gap holds $25 versus $3.75 per million, and because Flash uses 17% fewer tokens per task, the effective cost difference per completed workflow is even wider than the sticker price suggests. To be fair, Fable 5's thinking tokens bill as output tokens. So a max effort call can rack up 14,430 output tokens and cost around 72 cents in output alone on a single prompt. But if your tasks are simpler and you run Fable 5 at low effort, output drops to roughly 1,920 tokens. So the real cost depends a lot on how hard you're pushing it. Flash wins pricing, and I knew it would, but the 6.7 times gap is bigger than I thought it would feel in practice once you stack the token efficiency on top. Both models give you about 90% off on cached input reads, so that ratio is tied, but Flash's lower base means the absolute savings are still meaningful. That puts us at Fable 5.1, Gemini 3.6 Flash 2, Test 4, context window and long document handling. What breaks when a model's output cap is too small is you're synthesizing a 200-page technical spec into a full architecture doc. The model hits its limit halfway through and forces you to chunk it manually. You lose coherence across sections, and now you're doing extra engineering work that should be the model's job. I was expecting both models to be pretty much tied here since they both have a 1 million token context window. And on context size they are, but the output cap is where it splits. Fable 5 puts out up to 128,000 tokens per request, Flash caps at 65,536, and that's nearly double the single pass output. Fable 5 also has extended thinking with up to 32,000 plus thinking tokens for deep document synthesis, which Flash doesn't have documented. Honestly, for a lot of use cases, Flash's 65,000 output cap is more than enough, and most people aren't generating 128,000 token outputs in a single pass anyway. Flash also has an edge on multimodal inputs since it handles native audio and video, which Fable 5 doesn't document. So it's not a clean sweep, and it really depends on what you're feeding the model. Fable 5 takes this one, and I think it earns it on the output cap alone. I went in thinking both would be basically the same since the context window is identical, but 128,000 versus 65,000 output per request plus purpose-built extended reasoning for long doc synthesis is a real edge. That brings us all the way back to even. Fable 5 2, Gemini 3.6, Flash 2. So here's where Fable 5 clearly wins. Hard coding tasks, 80.3% on Sawi Bench Pro versus 58.7%. And that gap grows on complex problems. Single pass output, 128,000 tokens versus Flash's 65,000, so fewer chunking workarounds. Extended reasoning up to 32,000 plus thinking tokens for deep research and architecture work. And agentic reliability across 7 business task categories, where Fable 5's lead actually gets bigger as tasks get harder. And here's where Gemini 3.6 Flash clearly wins. Price, $7.50 per million output tokens versus Fable 5's $50, that's 6.7 times cheaper, and the gap holds at batch rates too. Latency, Flash maintains Flash tier speed, while Fable 5 sits at a 109-second TTFT you can't turn off. Token efficiency, 17% fewer output tokens per workflow than its predecessor. And native audio and video input that Fable 5 simply doesn't have. Honestly, I went in thinking one model would pull ahead cleanly, and it ended up 2-2, so the decision rule is pretty straightforward. If the task is genuinely hard, complex coding, deep document synthesis, multi-step agentic work where a wrong answer costs real money, use Fable 5. If you need speed, volume, or budget control, and the task doesn't require that level of reasoning depth, Gemini 3.6 Flash is probably enough and a lot cheaper.